Hello, my name is Beth Dixon, and I am the Math Lab Coordinator and work in the room 222 of the Math and Behavioral Social Science building. My job here at Walter State is to provide help to students in their math courses as they proceed to get their degrees here at Walter State. Um, these lessons on podcast are available to students to supplement the teacher's lectures and are not meant to replace time in a classroom, but to kind of give that extra help and that extra little bit on how to do the homework and how to study, and to give that extra little bit of help and answer questions, hopefully, that students need. So I hope this lesson on slope will be beneficial to you. But again, it is not meant to replace your teacher's lecture. In this case, we're going to start out, though, talking about what slope is. Slope is a very hard concept for students. And so if you're struggling with slope, do not feel like you're in this struggle alone. A lot of our students, I almost would say a majority of our students, really struggle with the idea of what slope is. So I did want to take just a few minutes as I do this lesson and these examples, to talk about what slope is by definition. And the nice thing about these podcasts is that these podcasts can be paused, and you can copy these definitions, or if you'd like a copy of these handouts that I'm using, if you'll email me or come by here in the math lab, I'll be glad to give you a copy as well. In this case, slope is a measure of the steepness of a straight line. Now, what does that mean? That means if we have a straight line, and I'm going to use this pencil as a straight line, we want to be able to measure how steep that straight line is. Is this line steeper than this line, than this line? And are these lines different in steepness than a line that goes this direction, slanting in the opposite direction? This one, if we think about it from left to right, seems to be going uphill. The ones like this, if we look at it from left to right, seem to be going downhill. So that seems to be different. So it is a measure that we use to measure the steepness of the line. Well, how are we going to measure? If we measure, it's got to deal with numbers, and we're going to compare two numbers. And the numbers we're going to compare as a ratio or as a division, because that's what a ratio is rise over run. Those are the most common words you'll hear, and you'll hear me repeat those quite a bit today. Well, let's look at what the rise is. Rise is simply the change, which is either an increase or decrease, in your vertical distance. You've got to rise up, okay? So rise is coming up or down. It's how much that changes, an increase or decrease, in the vertical distance, up and down. Run is how far out you go, either forward or backwards, so it's a horizontal difference. And when I drew these, my arrows were one way, but technically my arrows should point in both directions, because you can either move forward or you can move backwards, going left to right for your run, and you can go up or you can go down for your vertical distance. But it's a rise over a run. And how do you remember which one goes on top? Well, rise goes on top. How do we know? Because you have to rise up before you can run. You have to stand before you can run. So it's rise over run. Now, here are some real life examples, because what good is slope if we don't really use it in real life? Well, what has slope in real life? Well, roofs have slope, or what we call pitch. Pitch is just another word for slope when we're talking about roofs. Our plumbing pipes, they have to have a slope or when the water doesn't run out, it backs up if they don't have it. Landforms have a slope. If you go skiing, it has to have a slope. Surface runoffs, our roads, have to have a slope, otherwise the water backs up. And there's many, many more examples. But it all boils down to this rise over run, the comparison of those two values. And I wanted to show you one example here of the roof example. Okay? And I've got an example of a roof, and here's how you measure and talk about the rise of a roof. Okay? Here we have our outside wall, here we have our rafter, and there you've got your shingles. And this particular roof, you measure so many inches up and so many inches out. So this one right here is your rise. The horizontal distance is your run. Again, this is your vertical distance, your up and down, and this is your horizontal distance, left and right. So if we wanted to talk about the pitch or the slope of this roof, again, we would want to compare the rise over the run, which would be 7 inches to 12 inches, or a 7 to 12 pitch. Because pitch is the word that they use when they talk about roofs. So it's a 7/12 pitch, or a 7/12 slope on this roof. Now, luckily I don't have to crawl on a roof to figure out slope. I am going to figure out slope in a couple of different ways. One is to look at a graph. And I can figure out slope from a graph by looking for what I call corner points. And I think some of our other teachers use that phrase as well. I've kind of picked it up from them. But what you want to think about is when we look at a grid like this that we have graphed on in a Cartesian plane, that these grid lines mark whole number points. Here's 1, 2, 3, 4. If you're in between here, it's not a whole number. And as you go up, you've got 1, 2, 3, 4. And in between is not whole numbers. And that works for the -2's. I mean, negative also. So you've got -1, -2, -3. So if we're in the center of a block, then we're not on a whole number. To be on a whole number, we have to be where two of the grid lines intersect at a corner. Now, I don't know about you, but I would prefer not to be dealing with fractions as I'm trying to learn this new slope. So as I look at this problem, what I want to do is find corner points. And you're going to follow your line until you find a couple of corner points. And I'm just going to start going along from left to right. Why do I go from left to right? Because that's the way I read. I move from left to right. And I'm going to come along and say, oh, there's a corner point. There's a corner point. Oh, wait a minute, I skipped one. There's a corner point. And I could find all the corner points that I wanted, but really just 2 is all I need. Now, once I have some corner points, I can then talk about rise over run. M is the letter that we use to represent slope. So the slope, or M, and I'm going to again write the words rise over run. You want to keep those in mind. Rise representing the vertical distance, run representing the horizontal difference. I'm going to put my pencil back on one point, and I'm going to talk about how I move from this point to this point. Now, if I'm moving along the line, that doesn't give me a vertical change or a horizontal change. It gives me a diagonal change. And it goes straight across the diagonal of a corner. Well, think of these as city blocks. And if I'm walking in a city block and I go from this point to this point, and I go just like my pencil moved, rewind that and watch it again if you need to, and I go just like my pencil moved, then I'm cutting through somebody's property. And I'm sorry, I was raised that you didn't walk through somebody's property unless you asked permission. So we don't have permission. We have to walk on the sidewalks. The sidewalks are the grid lines, and we have to rise up the number of blocks we need before we run, because that's the rule. So we're going to rise one block and run one block. Do you see that? Rise one, run one. So my rise is 1, my run is 1. So this line has a slope of 1 over 1, which is 1. And it's positive. See how it's going uphill? Slopes that go uphill as we read from left to right are considered positive slopes. Now, let's look at our next example. And again, on this one, I'm going to try to find some corner points. And again, I'm going to go from left to right. And again, I find one right here. And as I go through, they're not as frequent as they were before. Wait a minute, right here's one. Right here's one. And down here's one. So I found some corner points. Now, for the problems in the book that you may be doing, you may not find as many corner points as I found here, but I marked the corner points. Corner points, again, are just so that we have whole numbers and not fractions. Technically, I can use any 2 points to calculate it, but it's hard to figure out unless I'm dealing with whole numbers, what the exact distance is. Because on a graph such as this, we're just estimating anything that's not a whole number. And I'm going to this time move from this point to this point. Now, there are other ways to do this, but if you're confused, you want one good way. So I'm showing you one good way. And that way is, I always want to move from left to right because I read from left to right. So from left to right, following the line from left to right, I'm going to move from this point to this point. And again, I have to go up or down before I move left or right. And I don't want to follow the line. I want to stay on the city sidewalks. And the grid marks of my graph are the sidewalks, not the line itself. So I'm going to go down and then over to measure that. Now, eventually you'll get where you probably will not need to draw these lines in, but it's okay to draw these lines in. They're not part of the graph. They're just the way that we're going to measure our slope, which again, we use the letter M to represent. And because we're learning this, we're going to write rise over run every time. So M equals. Well, we covered 1, 2, 3 city blocks. We went down 3 units on the graph. Wait a minute, what did I just say? We went down 3 units. So that has to be a -3. We didn't go up, we didn't rise, we fell 3 units. So that's going to be a -3. Then we ran 2 units in a positive direction. Now, again, there are other ways that you can get this answer, dealing with your signs and getting this -3 over 2 as your answer. But we want one consistent way. And so if you'll always go from left to right, your sign of your slope will always be in your rise. but only if you go from left to right. Otherwise, sometimes your sign will be elsewhere. And you're saying, that just confused me. Well, if you'll go from left to right, just always do it this way. As we look at this then, that gives us -3 over 2 as our slope, and that reduces down to 1.5 if we wanted to write it as a decimal, but slopes are always better in fraction form, so just -3/2, and that's the slope of this line. Notice this line has a negative slope. It slants down. Notice it's a little steeper down than the other one was up because it's a little bit more than 1. So it was a little quicker down. And so we have a -1.5 or -3/2 slope. Now, we can't always be given a graph to find slope, so we don't always count. Most often, we're given points to find slope or a table to find slope. So with a points or a table, we need a formula. And our formula for slope is m equals rise over run. Now, I'm going to bring back that first sheet. What did that first sheet tell us the definition of rise was? Rise is the change or the increase and decrease. Well, if you stop a minute and think about what the change or increase and decrease is, remember that those words all lead us to think about subtraction of the vertical distance. Well, and if we think about vertical distance on a graph is which value? Well, it's the y value. So for our formula, the rise is going to be the difference or the change in the y's. Run, and this time I'm not going to fly papers all over the place, but run, remember, is the change or the increase and decrease in horizontal difference. Horizontal difference is your x-axis, so it's the change in your x values. And again, I'm not giving the full lesson that I would if I was giving the class, but we want to find that. And a nice shortcut way of writing this formula is to put a little triangle, because that little triangle is actually meaning delta, which is a Greek symbol, and in math, delta simply means the change or difference in the y's over the differences in the x's, and then we don't have to write out all those subscripts. And again, I'm assuming your teachers talked about this because I'm not going to go into any more detail on this part of the formula. I'm just going to go into the practical part now of using this formula and these points to find slope. Now, remember we can subtract in any order. I'm just going to subtract from left to right. Again, that just simplifies things for me. 2 minus 6, the differences in y, over the differences in x. And since I started with the 2, I'll start with the 3. 3 minus 5. 2 minus 6 is -4. 3 minus 5 is -2. -4 divided by -2 is a +2. So the slope of these 2 points is a +2. Okay, let's do the next points. On the top, we get 3 minus 4, 3 minus 4 for the y's, because remember, there's your x. First numbers are your x's, the second numbers are your y's, and I'm just going to subtract left to right, 3 minus 4, and on the bottom, -4 minus a negative 8. Notice that even though that's negative, I get two negatives here. And I'm going to take an extra step to write this so that as I talk, you'll see. But notice what that does to the sign. Subtracting a negative makes that a positive. Now you'll just mark it here and make it positive, but I wanted to show you this so that as you're looking and watching the tape, you'll get the idea. 3 minus 4 is negative 1. Negative 4 plus 8 is 4, and so we end up with negative 1/4. Now, I've lost my formulas. I don't have them in sight, so I'm going to rewrite my formula. Slope equals rise over run equals y2 minus y1 over x2 minus x1 equals the change in y over the change in x. I'm subtracting my y's and subtracting my x's. Okay, now this time I'm going to subtract my y's. Negative 2 minus 2. Negative 2 minus 2. 3 minus 9. Negative 4 over negative 5. And we get 4/5. Oops. I'm still losing my slope formula. And until you have this slope formula memorized, you really should write it down every time you use it. Once you have it memorized, then you can stop writing it. A good way to memorize anything is to put it on an index card and carry it around with you. Now let's do this one right here. The differences in y's, 0 minus 8 over the differences in x's, 5 minus 5, negative 8 divided by 0. Now, do you see the problem on this one? If you do that in your calculator, undefined, I'm always afraid that as I do these that I'll come across and do a misspelled word that'll be out there forever. I will eventually. Now, as I do this, I'm going to type in negative 8 divide 0. And as you do that, notice what it says. It says error, divide by 0. You cannot divide by 0. Now, I'm going to take one of my graphs that I did earlier, and I'm going to plot those points real quick. 5, 0. Oh, I can't plot the well. And 5, 8. And it's coming off my paper here, but we'll pretend. And I've graphed those two very quickly on my paper. And what we have is a vertical line. And for our vertical lines, their slope is undefined. If it's straight up and down, then we're going to call that slope undefined. Because the change in x's, the change in the run, is 0. Because my x values do not change. There is no run. And we cannot divide by 0. So that is undefined. Okay, now let's look at the last example here. 3 minus, slope equals 3 minus 3 over 2 minus 6. Now when I take 0 divided by negative 4, just because we get a 0 does not mean we're in trouble, because 0 divided by negative 4, notice, is 0. So slope of a horizontal line, which is what this is going to be, and I'm going to graph these 2 points quickly, 2, 3, and 6, 3. That's the red line there. Notice that that's a horizontal line. Notice it really doesn't slant uphill or downhill. And our uphills were positive slopes, our downhills were negative slopes. This one has a flat line, so it's 0. And again, this is not to replace a lesson, so your teacher has talked about this in more detail. Okay, but there's an example of what happens when we get 0 slope. Lastly, let's look on to see how we can get slope from tables. And with a table, there's 2 possibilities. One possibility is that we know it's a linear equation, and we know that if we do 1 point, all the slopes will be the same. And the other possibility is that we don't know whether it's a linear equation, and we have to test to see if it's a linear equation by saying that all the slopes are the same. And um, and again, that's part of the lecture that I'm not going over. I'm just showing you how to find slope from a table. Well, the quickest way to find slope from a table is to do the subtraction. And we need to be consistent. We need to do the order the same. Just like we had to be consistent when using the table, when we did our points, when I start with this 2, I have to start with this 3 and always work from left to right. I can't start and say 2 minus 6 and then go 5 minus 3, because then I've confused the 2 points and I've created a new point. So we need to be consistent in our table as well. And if your teacher has told you one way to do it, you want to follow that way. And we can either subtract up the table or down the table. And it doesn't matter which, as long as you consistently do it one way. Generally speaking, our x's are always listed from smallest to largest. So the best way to get positive numbers on our x's is to subtract from the bottom up. There's also some other reasons why we do that. It has to do with some other math, and so that's just the way we were taught as teachers, and so that's the way we show you, and it gives you a consistent way to do it. Now, because the numbers are on a table, and because we're just going to put little arrows here to find the difference, use your calculator. And we're simply going to go 1 minus 0. That's going to tell us to subtract. I'm going to hit enter and get 1. 0 minus a negative 1. Here's why I'm telling you to use your calculator, because if you don't, you're not going to get the right sign. Negative 1 minus negative 2, positive 1. Negative 2 minus negative 3, positive 1. And I'm going to come over here and I'm going to show you that if on the x's we had negative 2 minus a negative 3, that would be negative 2 plus 3, which is a positive 1. Now I'm going to do the same thing on this side, and the y values will either be positive or negative based on what kind of graph we have. And I'm going to flip the calculator over to this side, but I'm just still going to do that same process. 3, subtract 1, enter. And I'm going to write that number down. 1 minus negative 1, enter. Negative 1 minus negative 3, enter. Negative 3, negative 3, subtract, negative 5, enter. Sorry if that part of that got cut off, but I was just subtracting the numbers, just as I said. And what do we have is you'll notice we have a very consistent pattern on both sides, but I still don't know what slope is. That's where we go back and we remember that slope is rise over run, y2 minus y1 over x2 minus x1, or how the y's change over how the x's change. Well, this right here told me how the y's change. How are the y's changing? 2 units, and every time the y changes 2 units, the x changes 1 unit. And that's consistent all the way through. So I know this is a linear equation, and it's 2 over 1. And actually, I think all of mine are linear equations. I didn't do the other example. I'm going to repeat this process for example 2 here so that you can see another example. Okay? 3 minus 2 is 1. 2 minus 1 is 1. 1 minus 0 is 1. And 0 minus a negative 1 is 1. Negative 10 minus negative 7, negative 3, negative 7 minus negative 4, negative 3. And if you know it's a linear equation, you really only have to do this for one problem. So read your question carefully and your directions carefully, because that could save you some work. Whoops, what did I type in wrong? I got one that's different. Oops, that's supposed to be a positive 2. Yep, that's supposed to be a positive 2. I can have typos too. I'll fix that on the handout if you get it, but it's supposed to be a positive 2, because then the slope, okay, look at our slope formulas there, is the differences in y's. How did we get this number? We subtracted our y values, so that's negative 3. Over the differences in x's, the change in x's, okay? How did we get this number over here? That change in x of that same group of problems. I can't come over here and pick this change. I have to stick to that same group. So negative 3 over 1. So this one has a slope of negative 3. Okay, let's do this example down here. Notice you don't always get 1 on the x values. And again, our slope is the difference in the y's over the difference in the x's. So the slope here is 1/3. I hope this helps you find slope using tables, graphs, and points. Thank you.